Yes, Jay, we are live now. We can start. And recording is also started.
Okay, thanks, Vishwan. So, good day to all the attendees of the camera and sensors for aBAJA webinar. I'm Jerin Jayachandran, and I, along with my co-host Anurag, extend our warmest welcome to our esteemed speakers of the day and special guests who are attending the webinar. To all our dear participants, faculty advisors, and all those with a keen interest in vehicle autonomy, thank you for joining us today. We have an exciting schedule lined up as we delve a little bit deeper into the newest edition of BAJA SA India, the aBAJA category. To begin this webinar, call upon a man who has been of immense support to the BAJA SA India organization in realizing the vision of aBAJA. Mr. Arun Shankar serves as the head of innovation at Continental Autonomous Mobility India and heads the activities within the Innovation Lab. So the Innovation Lab focuses on delivering incremental innovation, IP creation, new business incubation, and constructing strategic partnerships to enrich the company's product portfolio. He has been awarded with the Silver Continental Automotive Award, which is an acknowledgement to his outstanding achievements, extraordinary dedication, and exceptional creativity. With over 2 decades of industry experience, Mr. Shankar is a distinguished inventor with 12 publications and 17 patents to his name. Without further ado, I invite Mr. Arun Shankar to deliver the welcome address.
Okay, thanks for the introduction. I hope I am audible.
Yes, sir.
Um okay. Um, of course, I have a couple of slides to start with, but I would want to share one article from Yahoo Finance before I can start my presentation. Let me share my screen, please. Um, is my screen visible?
Yes, sir.
Okay, so this is a article from Yahoo Finance, which was released in January 9th. It talks about how big is the autonomous vehicle market size. Uh, uh, it talks about how much it was valued at year 2021 and how much it will hit by 2030. And this number, whatever year I have highlighted, is a very, very big number. Huh? And look at the rate at which it grows. Huh? So the growth rate is huge. The amount of market size this autonomous vehicles will have is also extremely huge. Huh? So what it means is that this is going to generate lot of jobs everywhere across the world. Hmm? So that is why I would really congratulate each one of you who volunteered to really be a part of aBAJA. Volunteered means participating or being involved in this competition in some way or the other, because whatever skills that you will learn during the course of this particular competition is going to really help you to really get a share of that market size. I mean, basically it will translate to jobs and finally it will result in value creation for you. Right? So anyway, this article I showed just to say that this is going to be a big job creation technology. So please, utilize this as an opportunity to learn about how autonomous vehicles will work, and how how AI is really playing a great role in this, in making the autonomous vehicle a reality. So welcome on board. So with that, I would want to jump to an presentation which is not too long. Well, I will take about 5 minutes, not more than that. So we at Continental, we are a large automotive tier one company. When I say tier one, we develop several systems and components which are required for the automotive industry. And one of the big verticals business groups that we have is called autonomous mobility, which is basically a business group which is targeting at the big market, which I showed in the earlier article. So we at autonomous mobility business area, we develop sensors and systems with which vehicle becomes autonomous. So when I say autonomous, it is not fully autonomous, but it is more a sort of semi autonomous mode. Maybe a level 2, and a level 2 plus is what we have made a reality up to now, and level 3 we are slowly moving towards that. Under circumstances, level 3 has been achieved. Okay, so well, we have been developing several sensors like cameras with which the vehicle can see the world, several sensors like lidars with which the vehicle can sense the world as to how far or how yeah, what is the distance between the vehicle and its one of some surrounding obstacle. And radars too, radars again also, it's about feeling. The vehicle can feel how far another obstacle or another vehicle is in front of it. And so these are the three sort of sensors that we develop so that we can make our vehicles autonomous. And there are several control units called as automated driving control units, which are more supercomputers inside vehicles. So these are the different things that we developed. Along with that, we also developed several software, because software is a game changer now, and vehicles are today computers on wheels, and they uh, they are we are in the era of software defined vehicles. What I mean by that is software will define what features are offered by a vehicle. So companies can really push software through air to the vehicle so that the vehicle suddenly transforms to a slightly different one, right? So that is a sort of effect software has in today's automotive world. And we develop several softwares which are required for making the vehicle autonomous. So we have a good track record of developing all these for several OEMs, for several brands, several models, and we have a very strong history of delivering several million units to all these major players. So with that, I would want to say that just one type of sensors is not sufficient. We look at multiple types of sensors, because certain sensors like cameras, they might work in one scenario, but they will not work in some other scenario, right? So there is always pros and cons of each type of sensors. That is why we use a combination of sensors. But when it comes to aBAJA, we don't need all sorts of different sensors, because it's a very controlled environment in which the vehicle runs, and it's a moreover, it's more a student competition, right? So that's where we think that from Continental, we think that radar is definitely will be of great use, and camera also will be required, but maybe lidar and others are not required for this level of autonomy that we are targeting in aBAJA. So we at yeah this is one of the what goes inside the software and the hardware which I showed in the very first slide. So there are set of sensors, and there is a good amount of AI, artificial intelligence, which is used to really process the feed coming out of these sensors, and good amount of abstraction or information is extracted, saying where the vehicle is. That's what we call as a localization, and where are the free spaces around the vehicle, and what there is a fusion happening. Different sensors will say that these are the different objects, but all that is fused within a central computer, and a single representation of the environment is made. That's what we call as an environment model. And based on the sensing part, path planning is done, and later some actuation is done as to braking, acceleration, or so on. So these are the different challenges that we foresee. Uh, Humans can very easily detect these are the different cars, but can the computer inside the autonomous vehicle, can it detect? That's a challenge. uh, this is what humans see. The computer will see these as people, but can it predict what happens in the very next minute, whether these people will go walk keep walking, or whether they will change their mind and go back. All that are challenges, right? What they do in future, we have to predict. And given all these such certain scenarios, where can I go is what the vehicle can has to really determine. So all these are quite challenging tasks, which will have to be attacked, will have to be addressed by when we really make the vehicle autonomous using software. And AI systems can be fooled. Uh, this is a image which a computer sees and recognizes with 57% confidence as it is panda. But you add some noise onto it, the way image looks very same, but the AI algorithm, which would have earlier detected it as panda, will start detecting it as a gibbon, with such a high confidence. So that's AI systems can be fooled, but humans don't get fooled, right? So these are the sort of different it's a difference between what humans perceive and what computers perceive. So object detection is of paramount importance, and somehow the students who are working on this particular challenge, they will have to really detect several such objects using the machine learning algorithms, which will process the radar or the camera feed which comes from the sensors. And that's the challenge that the participants of this competition will have to go through. Hmm? So this is just another way of doing the autonomous vehicle development. But in aBAJA, things will be relatively simpler. That's what you'll see in the upcoming rule books. Data management will be challenging because each of these sensors will be generating a lot of data. uh, Precision is required despite we having limited memory speed and cost. There are some boundary conditions. Despite that, precision will be required. Technological competences will be required. It's not just about mechanical engineering or pure electrical engineering. There is also computer science and several other new cross domain expertise that will be required. So ensure that your team has several of those competencies as well. Then we have to really accommodate several conditions. For example, sign recognition. It's not just about signs in India, but signs in US or signs in Arabia. So different. The vehicle has to really work well in all of those conditions when it comes to development at companies like Continental. But maybe within your the competition, student competition, it will be relatively straightforward. But yeah, just wanted to highlight that it's a challenge. Then things have to be real time. So the moment the vehicle, the sensor sees some object, within fraction of second, it has to really brake or act, right? Vehicle has to act. So time is important. Reproducibility. If something goes wrong in testing, we will have to be able to reproduce it and fix it so that such a problem doesn't come in real world. Uh, then simulation of driver behavior is important. Maybe not in your challenge, but definitely in our real world industry scenario. Rapid prototyping is quite important for us because there is a lot of scenarios to be tested in virtual sense, and that's where we have to really quickly make some prototypes, simulate it, test it. Then yeah, something might not work. We come back, we quickly redo the prototype, tune some parameters, go back to simulation. So there's a lot of iterations, a lot of quick things to be done to really get onto the road. Uh, and a lot of these algorithms or a lot of things are also sensing technology dependent. For example, an AI algorithm which works for a radar will not, the same thing will not work for a camera. So you will have to have different flavors of AI algorithm for camera, radar, and yeah, that's the challenge. So I'm just trying to summarize all the challenges that we at Continental are facing when we are really getting into this sort of development. But definitely, I think for your aBAJA things will be relatively simpler. So I would want to stop here. Yeah, feel free to contact me. And we from Continental, of course, we are planning to also look at how we can support this by providing some sensors. Yeah, there are some internal approvals which we are going through, but I think it should be more or less through in some time. And yeah, later today we also have a technical talk from my colleague from Continental, who is an expert in camera. So that will give you a glimpse of how camera sensors are, and that will help you to really also when help you when you are into well into the competition. Okay, so thank you, and I will hand over the presentation to Dr. Vora, or maybe the MCs. Yeah, thank you all for the moment.
Uh, Thank you so much, Mr. Arun Shankar, for sharing your valuable knowledge and the role and importance of Continental in aBAJA. And now I would like to invite Dr. K.C. Vora to share the journey and how the birth of aBAJA took place. Dr. K.C. Vora is one of the founding members of BAJA SA India and former chairman of the organizing committee and the current advisor. He is Professor Emeritus at College of Engineering, Pune, and the chairman of ASGC Expert Group on Electric Vehicles. He has around 20 years of experience in automotive industry and has always played a pivotal role. That's all from my side. Over to you, sir.
Hello, good evening, everyone. Am I audible?
Yes, sir, you are.
Yeah, Sharon, you can start the presentation.
Yes, sir.
So it's an honor to talk today on the autonomous BAJA. When I'm talking to you, I'm very glad to inform you there are 15 teams who have registered for autonomous BAJA from India, spreading across India. And it gives me so much of satisfaction of what we thought before a few years and what we are doing now. I would just tell you the history of autonomous BAJA. Just go to the next slide. Jerin, next slide. Yeah. So the birth of aBAJA happened, I must say it must happen somewhere in 2020, when someone sent me details about the GM design challenge. So in USA, they already have an autonomous car project through SAE International, and GM General Motor is funding this event. And they gave cars to each and every team and they gave 3 years to convert their car into an autonomous mode. When I heard about this, I said we must also in India also we must start working towards autonomous BAJA. In USA, it is not an autonomous BAJA; it's an autonomous car competition. We said it is not possible for Indian industry to give a car to the students, say 15 cars or 20 cars. Neither it is possible for the students to buy a car and convert into an autonomous mode. So what do we do? So we came up with this idea that between mBAJA and eBAJA, it's very easy to convert an eBAJA into aBAJA. So only those teams who have participated in eBAJA can convert their eBAJA vehicle into aBAJA. But then the question was that there are very few teams, maybe 100 teams who have participated in this last 3 years, 2021, 2022, 2023. So we came up with an idea that the team who registered for eBAJA in 2024 also can participate in aBAJA 2024. We will keep a 2 months gap between both the events so that when the vehicle comes back, they have to just put up the sensors, actuators, do some trials, and they are ready for the autonomous BAJA competition. So that was the idea. So somewhere in 2020, when we started working, Jarin can go to the next slide. I talked to some of the younger people that we need to start working, our alumni committee member, that we need to start working on it. So we did a benchmarking. We tried to find out what world is doing on benchmarking. And we found 3 names. One is called Ernst Dickmann from Germany. He started working on autonomous cars in 1980 and did make a prototype. Then in 1925 in USA, Francis Hodina came up with autonomous car. It was a Mercedes-Benz car. And in 1939, Normal Bell Geddes from USA also made autonomous car. And then many companies came forward to start producing autonomous car. Many countries like German and USA started giving license to the autonomous car. Today, yes, we have autonomous car being sold. Not, oh my God. हे चालू आहे का? बंद झालं. गणेश, बंद झालं देख, चार्जिंग होत आहे का? होत आहे. माऊस आहे माऊस. इथे येऊन लाव. Am I audible?
Yes, Vara, sir, you are audible.
Okay, but I'm not able to see the screen. Something went wrong. Yes. Okay. So now I'm able to see. So we did this benchmarking. We also did benchmarking of various competitions happening worldwide. So the first competition on autonomous car was in 2004, where DARPA, that is Defense Air Research Project Agency, started a competition. Then in 2010, we have WISLab Intercontinental Autonomous Challenge. And then came GM Design Challenge. And now in India, we are starting this competition called aBAJA, Autonomous BAJA. Next slide. So to start with, I talked to one of the alumni committee members, Aditya Chaugule, who is now in USA doing his master's, and Rugved Ainapure and Vishwam Pancha. So these are the three people to whom I'll give credit, who had series of meeting to develop the rules and regulation in the rule book of autonomous BAJA. And that's how the autonomous BAJA was born. And the rule book was just released last week. So it's my special thanks and appreciation to all these three young who have helped me to. And then Saurabh Suman refined this and released this rule book last week. Let us see what are the salient features when Rugved talks to you. Jerin, can we go to the next slide? But it is very important that there are three supporters who supported in this event. One is ATS, Automotive Test System. You are aware of him because they have given us IPG car maker license. And Mr. Ramnathan of ATS really gave us encouragement, said, don't worry, we will start the event, whatever happens. I'm there to support you. Whatever you want, you just tell me. That gave us so much of confidence. And then he connected us to Continental, and then Continental came forward and said, we will also support you. So Continental is a very big team sitting in Bangalore who is working on autonomous technology. And they said, yes, we will also support you. And that's how we got confidence, and we said, let's do it. Yes, in the background, it is ARAI, where I worked, and I have seen the technology group who have worked on autonomous cars long back, before 10 years. And now a lot of work has been done, and ARAI has already signed an MOU with Continental, and they have said that they will also support us. So with blessings of these three companies, ATS, Continental, and ARAI, we are going ahead with autonomous vehicle. Yes, there are so many loopholes. There are so many things to be done, but I'm sure all of you will support us. And I'm sure the 15 teams who are participating will understand the change we are going through. And I think we need to embrace this change and move ahead if our country has to get a strong hold in automotive technology. You all know that we are the top 3 vehicle manufacturer. In 2006, we were the 11th largest vehicle manufacturer in the world, passenger vehicle manufacturer in the world. In 2016, we were the 5th largest passenger vehicle manufacturer in the world. And today we are almost 3rd after US and China. Automotive industry in India is really doing great with the support of Ministry of Heavy Industry and the government. And we have a very good, strong SIAM, that is Society of Indian Automotive Manufacturer, and Tier 1, Tier 2, that is ECMA, Automotive Component Manufacturers, supporting them. So there is a very good ecosystem. You have seen that how we have moved ahead and met the BS6 emission norm, and we are now talking about BS7 norms. We also seen how our country has jumped into electric mobility field, and just before 2 years, there were no electric vehicle except one or two. Companies like Reva Electric started producing electric vehicle long back, and then Mahindra took over. But in this last 2 years, there are 25 two-wheeler manufacturers who started producing electric vehicle, and we already have 5% penetration of electric vehicle among two-wheeler industry. And I'm sure in passenger car also the same thing will follow. Similar to electric vehicle, I feel that autonomous cars also would come very fast. Already in Dubai, we have autonomous car which serves pizza. You just make a call on your, just give an order on your cell phone, and the pizza car would come home. You have to just open the door and the pizza is there. So we are moving into that age where we have to move very fast with the technology. And if we are not able to move fast with the technology, we perish. So it is said that by 2025, 80% of the jobs will become redundant. The technology is moving so fast, we need to keep pace with it, and we need to understand and learn all these things. So many people will have to reskill themselves. Those people who are working on IC engine has to reskill in electric vehicle. And I'm not saying IC engine is going to go away. Again, it may come back through fuel cells and hydrogen. So, but it is what is important for all of us to understand is that we need to embrace this technological change and move ahead in our life, right? Let's go to the next slide. So okay, Jarin, you can go to the next one. When we started registration, we were very skeptical, and I told Continental that there may be 10 teams or there may be 20 teams. I'm not sure how many teams would be there, but I'm surprised to see that there are 15 teams who have registered and who have taken a challenge as the first team of autonomous BAJA. I remember in 2007, we started aBAJA. There were only 27 teams. And this year for aBAJA, there are 15 teams. This 15 team would always remain special for us because they have guts to participate in this event. And the spread is very good. We have team from South, we have team from North, we have team from West, Maharashtra, Karnataka, Kerala, Uttar Pradesh, Telangana, Gujarat, Haryana, Madhya Pradesh, Tamil Nadu. So each and almost major states are represented, and many winners who participated in aBAJA and eBAJA, like COEP, Technological University, D.Y. Patil College of Engineering, Birla Vishwakarma Mahavidyalaya, Sri Vishnu All Girls Team, and DJ Sanghvi College of Engineering in Mumbai. So I can see very, very familiar name who have agreed to participate in this event. And I must tell you, there are two all-girls team, B.V. Raju Institute of Technology and Sri Vishnu Engineering College for Women. So this time among 15, we have two all-girls team. And it becomes our duty to ensure that we give you very good training. We give you those kits, camera and radar, and we give you a series of training program. So today is one such training program where we are going to talk about camera. And then very soon you will get this camera, and then you will also get a radar. I will not be able to give you more information as time goes. You will understand that how automotive industry is working hard to support you and take it forward. So let's go to the next slide. So with this, I wish all the best to all these 15 teams. And I must say that I'm very happy to get into this, and I'm very happy to see that how this competition will move forward. And maybe after a couple of years, we will have 100 teams and 100 cars running on the track without driver. That would be a marvelous thing to see. And my eyes are just waiting for that to see maybe after a couple of years. Thank you very much, and wish you all the best.
Thank you very much, Vora sir. for detailing the notion behind the inception of aBAJA. Your explanation has shed light on the visionary nature of this initiative, and I'm sure the participants are excited with the opportunity to fabricate their own self-driving vehicles. So thank you, sir.
Thank you.
Let's dive into the crux of today's webinar. Our next speaker holds an impressive background in systems engineering and project management for various automotive projects, and spanning over 18 years of experience, he brings a wealth of technical expertise to the table. He has extensively worked in the ADAS domain for system analysis, requirements elicitation, system architecture and design, integration, verification, and validation, to name a few. His shows his expertise in providing effective technical architecture with experience in the image sensor and ECU interface for developing hardware in loop systems for testing camera sensors. I now invite Mr. Venugopal Kulkarni, Senior Technical Architect, Continental Automotive India, to lead the session on interfacing of cameras and sensors within the ECU for aBAJA.
Yeah, thank you. Thank you all for the good introduction. Thank you, Arun, and thank you, Dr. Vora, for the brief overview. With this, I would like to share my screen. Just a moment. Yeah, is my screen visible?
Yes, sir.
Yeah, okay. Thank you. Just to start with the overview, like what I will be speaking today would be on the basics of the camera and how are we interfacing this with the ECU. Based on my experience of connecting a camera to the ECU, I would be taking you through the experience, my experience. Just an introduction. So I am Venugopal Kulkarni, working with Continental for over 7 years now, and I have been designated as an expert, and then I work as an architect for this camera hill topic. So based on my work environment here, like it's like I work as a camera hill development engineer. So over this experience, I have gained insights on how the actual camera works along with the ECU. So what you will be learning today, it's like at a high level, like what are automotive cameras, different types of automotive cameras, and high level block diagrams for these cameras, and camera and ECU interfaces. So what would not be covered in this session would be the in-depth architecture or a development stack completely of these cameras. Target group is like, based on it's like the students from this particular projects who are participating here. And as I earlier mentioned, like it's an overview of automotive cameras and how these cameras are interfaced with the ECUs. So just to start with, like what we as a camera the group here, we are working on different cameras, like what we call it as a smart camera here. These are the smart cameras, like the cameras are within this one particular enclosure. We have both camera and the ECU connected here. And these are the satellite cameras where we have only the cameras and we connect it externally to the processing unit. So how this is done, we can look at further. So this is a high level block diagram of the smart camera, what we looked in the previous slide. So when we see a smart camera, when we say it's a smart camera, it's like we have a camera which is connected to the SOC or the processing unit or the ECU, what we call. So it's multiple terminologies what we use. So here we have the imager, and in front of the imager we have the optics. Optics would be nothing but a lens, how the field of view is coming into picture here. And this imager is connected to the sock over the different interfaces here. Maybe it could be parallel interface or the CSI2 interface. The details we would be seeing it in upcoming slides. So we send the image data, and there is a back channel communication from the ECU to the imager, which is over the I2C. So these images could be from various suppliers, like uh, you could already have been doing your study, like who are the imager suppliers. To name a few would be Aptina or Omnivisions or the Samsungs or uh, Sony imagers also, which are available. So what we do is we take this imager, we connect the optics necessary for our particular sensor. uh, Say for example, one imager we take, and based on the different uh, optics module we can change the field of view. So uh, if we have to look at a very far distance, then the field of view is reduced, and if we have to have a wider field of view, then the distance would be reduced. So based on that we choose the optics and also the images. And other things part of this block diagram would be like the vehicle bus, like for example here we have the CAN, the power circuitry, like we are powering the ECU over this circuitry, and from here this ECU in turn is powering on the imager, and we have the RAMs and the EPROMs here. So this is a high level block diagram. So this is a smart camera. Why we call this as a smart camera is we have the processing circuitry or the ECU or the brain here already connected directly within this uh, enclosure. So in one enclosure we have the imager circuitry and also the ECU connected here. So that is why this is called as a smart camera. So next in line we have something called as a rear camera. Rear camera also to an extent is a smart camera because we have a arm controller connected here. Um, so again, here we have the lens, we have the image sensor similar to what we had at the previous slide. So image sensor which captures the image, pre-processes it, and sends it to the ECU here. This could be a very simple ARM Cortex chip which is processing and sending the data out on the Ethernet. So in the previous slide here, we see the images are directly fed here, and the output, all the processing, everything is happening here, and over the vehicle bus, we are sending the actuator signal output on the output bus. So it's like sense, plan, and act. Everything are happening here. But when we come here, it's the sensing part is happening. Planning part, okay, though this is a very simple planning, like this rear camera comes into picture only when the we put the car into a reverse gear. Only then this rear camera comes into picture. So that is how this rear camera works. Here again we have different interfaces here, maybe MIPI CSI2 or a parallel interface. We again have the I2C interfaces for back channel communication. We have to sync the processor and the imager. So we have the sync signal, we have the clock signal, so that both the both imager and the ARM chip works on a similar clock so that the reception of images and processing of images happens in sync. And once this is processed, then over the broader reach pin, we are connecting back maybe to a head unit or our display unit. So wherever this intends to be connected. Again, here we have the power management circuitry. So this is a rear view camera. This is again a smart camera, but not as powerful as the earlier uh, slide. Coming to the sat cameras. So satellite cameras, here it could be, we can call it as satellite cameras or the surround view cameras. Based on how and where it is mounted, it goes by different names. Again, the basic architecture remains the same. It's like we have the lens, we have the image sensor here, and within the image sensor, the pre-processing happens. Again, we have the MIPI and the parallel outputs from these. We have the clock, we have sync signal, and the I2C signals. This sync signal, F sync, is one signal of importance here when it comes to satellite cameras, or when we say satellite cameras, it does not have a brain of itself. Like it here, we are connecting this to the serializer and not to any uh, processing unit. So this serializer is just for the connectivity. It takes all this information and connects, say for example, based on what kind of serializer we are connecting, it connects the output on the coax into that particular format. Here, if we are taking the example of a Maxim based serializer, then this would be GMSL2 or GMSL3 format. So over the coax connector, we are connecting it to the central processing unit or the domain ADAS unit, where multiple cameras or multiple sensors would be connected, and this is the brain. So we get all the sensing part from these multiple cameras, the radars, and all other sensors. Previously, what Arun mentioned, it could be the lidars, the ultrasonics, everything is connected to this ADAS, and from ADAS, uh, the various algos are uh, functioning. Okay, so here, and this F sync signal, the importance of F sync is, since multiple cameras are connected here, so all the cameras needs to capture the images in sync. So that is where this F sync signal comes into picture. So that is how this F sync is also controlled by the ADCU unit. When I say ADCU, it is the central processing unit for this particular camera. So these are few cameras what Continental at Continental we are working, and so a generic block diagram of how the camera and ECU are interfaced. So we have the camera. So here the camera, when I say it is all the image sensors what Conti is working with, we have this camera and we have this ECU. This ECU could be connected directly with the camera, as in our smart cameras, or uh, connected to a satellite processing unit or the central processing unit, where we connect over the serializer, deserializer lines, or we can discuss that. So how it is connected? We have the first interface as the camera control interface, or the CCI, or the I2C data. This is how the ECU controls the camera or configures the camera for sending out the images. So image data signals could be either the parallel interface or the serial interface. So what are these? We will look into it in the next slides. And uh, the power lines. So here for all the uh, ADAS cameras, so ECU is the master mainly in most of the cases. So When we say master, so the camera would be the slave device. uh, ECU would configure the camera based on how we want the images and at what time frame we need the images. Based on that, the ECU configures the camera over this CCI or the camera control interface, that is the I2C interface. And based on that, the camera sends the images to the ECU. So how this is done? So I think most of you would be aware like what exactly is the I2C interface. I2C is nothing but a inter IC communication. So when we say inter IC, so like both imager chip and the ECU are nothing but some ICs. So they are connected over this I2C connector. It's a two-wire bidirectional half duplex. So this is just a I2C briefing like what it is. It could support up to 4 kilohertz of frequency and 7-bit slave addressing. So here, as I said in the previous slide, like ECU is the master in most of the scenarios. So and the camera is configured as the slave. So we could configure multiple slaves from this single master. That is, for example, we can connect multiple cameras or multiple sensors to this ECU master. So the ECU, when we connect the camera to the ECU and power on the ECU, ECU in turn powers on the camera, and as soon as it powers on, ECU requests like what kind of camera is connected. So it requests for the identification from the camera, and camera acknowledges with the requested details over this I2C lines. And then once the camera is identified, okay, the ECU understands, okay, this is the camera what I was uh, expecting. Once that is ticked, then it goes on to configure the camera uh, based on some pre-configurations like uh, what should be the uh, field of view, the pixels, the starting point and the ending point of the addresses, how what should be the frequency, like the FPS, what we call that 30 FPS, 25 FPS, and how the image should be, like what should be its exposure. Based on multiple camera parameters, everything could be configured over this I2C lines. So once this configuration is done, then the ECU sets a register uh, to asking the camera to enable streaming. So this in turn, like say for example, there is a ECU, there is a camera, we connect this camera to the ECU and then power on the camera. Once the camera is powered on, then this identification happens. After this identification, some configurations happen. After this configuration, some quick tests happen, like whether the connected camera is working correctly or not. Most of you would know, like there are some built-in self-test. As soon as we power on any chip or any ECUs, a self-test happens. So all these tests are happening once everything. So all these things happen within some milliseconds. So 400 to 500 milliseconds. All these things are happening. Once everything is correctly set, then the ECU asks for the streaming enabled, to which the camera responds and starts streaming these images. So these could be somewhere why this is necessary, because just to have everything foolproof, we should make sure that an unknown camera is not connected to this processing unit, so that the threats are reduced. There are the cyber security, the functional safety, everything is coming into picture. So just to make sure we are addressing all these things, uh, this I2C communication is happening, and through this I2C communication, the ADCU or the ECU is controlling the camera. So once this thing is happened, then the images are sent, and even when the images are flowing from the camera to the ECU, there is continuous monitoring of these images. If it sees there is some mismatch, then if there is a mismatch in the image frame for continuously, say for example 10 is just a random number what I'm giving. If the 10 frames are mismatch, if there is a mismatch in these 10 frames, then the ECU will automatically go into reset stage or in the standby mode, saying that there is something wrong on it. It shows, it sends to the user. So after this quick overview of what is happening on the I2C lines, we next move on to just to see what is a camera parallel interface. So this parallel interface, when we say, as the name itself suggests, so based on the bit depth of the image, like 8-bit depth, 12-bit depth, or 16-bit configuration, uh, so many data lines are configured. Say, for example, a generic example should be like 12-bit depth. So each pixel has a 12-bit depth. So then in that case, we would be requiring the 12 pins from this camera to be connected to the ECU, and this each pin will be sending the each bit information from this camera to the ECU. So all signals are transmitted by the camera and received by the ECUs. The ECUs configures the vertical sync and the horizontal sync. This is the sync signal, how the image frame is read. Like it has a vertical sync and the horizontal sync based on the pixel clock. So image data is output for each rising edge of the pixel clock. So here, if you see, we have the pixel clock. Each rising edge, we have the horizontal sync, and each rising edge of the pixel clock, the image is sent, and this is a process based on the vertical sync and the horizontal sync. So horizontal sync is high while clocking out the active image data and indicates that one line. So if you have, if you could visualize a image frame, so one line is active for that 1 pixel length. Active image is transmitted and vertical sync is pulsed high at the start of each frame, and once this frame is completed, for the next frame again the vertical sync becomes active. So that is how the uh, camera is configured and the images are sent in this camera parallel interface. So some limitations of this parallel interface, this could also be advantage also, the because all the data is sent in parallel, but there are some limitations in this camera parallel interfaces. So with increasing bit depth, based on our ECU's processing, like how mature our algo needs to be there, so we request for higher bit depth. So initially algos would work at the 8-bit depth, 8-bit depth. Now the current cameras are somewhere around 16 to 24-bit depths as well. So here to address 8-bit, we need 8 pins. For 12-bit, we need 12 pins. As the bit depth increases, the pin count increases. So this would be having limitations on the performance and also the complexity with respect to the PCB designing and other things. Also, as the number of wires are increasing, here there could be reliability issues, and even a small issue with the PCB connection or a small disconnection, the whole uh, camera to the ECU interface would not work. So as the bit depths and at the higher data rates, it's always better to have a serial bus than to have the parallel uh, interfaces. So though it has some advantages, but it also has disadvantages. So for that reason, we are also using something called as a CSI2 interfaces or the camera serial interface. This is derived mainly from the MIPI standard. MIPI CSI2 is what the standard name. This is the name for this. MIPI CSI2 is if the MIPI standard, if we have to expand this, this is the mobile industry standard. So as the name suggests, this was designed for the mobile industries, which was adapted by the automotive industry. So here we have two different clock signals, a pair of clock signals, multiple pair of data lines. That is, data lines could be four different data lines. Okay, and that is how just by a pair of clock signals and 8 data lines we could configure any bit depth. So this is a standard unidirectional signals. We have the physical layers D5 and C5, which I am not going to cover in depth here. So we could manage the lane management, like these lanes are scalable. So if our use case or the uh, data what we need is at a lower frequency, then we could configure only one or two CSI2 lanes, remaining no need to be configured. So this is the configurable protocol. So CSI2, we could scale this. The number of data lanes can be 1, 2, 3, or 4 depending on the bandwidth requirements. So bit level and byte level synchronization for serially transmitted data could be handled. Uh, so we could also define how we want to pack the image pixels. So it could be like two different pixels within one exposure could be packed in a different way. I don't want to get into this much of details here. It could be interleaved or a standalone transmission. Everything is possible here. So and most of this could be controlled in a very efficient way. So there are, it's also possible to have a virtual channel so that we could transfer multiple exposure lines. Say for example, the camera uh, captures the image at one particular exposure and it processes for different exposures and could be sent in multiple virtual channels. So up to 4 peripherals are supported here. So this is how the CSI2, and mainly the industry is now moving towards the CSI2 interface very quickly. So yeah, I think there is some mix up here. Okay, so there are three different physical interfaces which I covered in previous slides. Just a summary slide here. It's like we can directly connect the camera to the ECU using a, a simple ribbon cable or a camera ribbon cable or a PCB direct interface. So here the limitation with this is as and how the length of the cable here, the interface cable increases, the bandwidth decreases. So we have to make sure that this use case we can have it in smart camera where directly our images are directly sitting onto the processing unit. So here uh, we could have a very small within 1 or 2 centimeters of the camera cable, we are connecting it to the ECU, and in that way the bandwidth is not affected. Uh, very uh, yeah, in a negative way. But if we have to connect our cameras or any cameras to the central processing unit or the ADAS controllers which are sitting, and we have to connect the multiple cameras or the surround view cameras, uh, anything here, then we go by serializer deserializer pair. It's like on the camera we connect a serializer, the output of serializer over the coax, we connect it to the deserializer on the ECU. The deserializer receives this data and again converts it back into the CSI2 or the parallel interface, and it gives the information to the ADCU or the ECU. So here, in a way, with this, the advantage is that uh, the coax connectors can run into some meters. Say, for example, 5 to 10 meters length, we can run these cables. So in this way, we could make sure that the ECU is sitting somewhere in the central location in the car, and the surround view cameras can be mounted anywhere in the car and could be connected over the serializer and deserializers using the coax interfaces. There is also another interface called as a broader reach interface. This is nothing but the Ethernet interface. Again, the advantage here is running uh, like we could mount our ADCU or the central processing unit at any um, uh, location within the car, and then we could connect the surround view cameras to the ADCU unit. So these are different interfaces what we are connecting. Uh, the highlights of the CSI2 is it guarantees like we can work with high bandwidth with between the cameras and the ECUs. Uh, it's like uh, uh, the image data is packet and sent to on a physical layer and sent it to the ADCU. So it's not bitwise, or the pixel information is not sent directly. So data is transmitted using the differential signal and with a dedicated clock over the physical layer. So here the uh, number of pins used does not depend on the bit depth of the image pixel. uh, we could uh, the image pixels are of the fixed signals. If our use case says lower bit depth is needed, then we could configure only the clock signals and one or two CSI2 lanes. With that, only minimum number of pins could be used, thus reducing the complexity. If we need more bit depth, then we could configure 3 and 4 as well in the CSI2 channels. So maximum we need only the 10 lines in this CSI2, so that it does not directly depend on the bit depth of the imager and the CS on the image frame. So this is a standard, a well-defined standard, and also well-controlled. We have a very thorough documentation for this standard and can support up to multiple channels exposures using the virtual channel, as I said here. So there are multiple literatures available about the MIPI CSI2. MIPI CSI2 in itself is a very matured industry standard, so we can get more information on this. So I think I am coming to end of my presentation. Just before I close, like how does a typical image frame looks and what we are doing here. So this could be the active pixel, what we could be sending um, each pixel, actual image. We could be sending it to the ECU. Say, for example, if we say 30 frames per second is our requirement. So what exactly is that? We could be sending 30 such image frames within a second to the ECU. So what does this each frame consist of? So we have the blanking signals, horizontal blanking and the vertical blanking. These are just for some pre-filling and post-filling data. We have a active image. This active image is nothing but the uh, bluish green shade what you are seeing here. Here resides our actual image captured from the uh, uh, surrounding environment from the camera. This is the actual image. Uh, so embedded data and statistical data, or the statistics data, these are two important set of information which we are adding as a header and footer to the actual image. So embedded data is nothing but this register data at the top. At the initial part of my discussion, I said that there will be continuous I2C communication happening between the ECU and the imager, and we are configuring the camera or our imager through the I2C data. So these are nothing but the I2C registers. We write all the register information, and at on top of each frame these register informations are provided. So it could be 3 4 lines of data where each and every register information is embedded onto the every frame. This is just to make sure that each frame is captured as per the expected timelines and with expected exposures. So these embedded data contains different configuration of the images that is being displayed. So this includes the register settings used to capture the current frame. If I had to get into a little bit depth here. So, for example, say uh, a image is sent, a set of images are being sent to the ECU continuously. Say, how will we come to know if a camera gets stuck somewhere and the same image is repeatedly sent to the ECU? ECU will not know. How will we make sure that ECU understand that the camera is stuck at a particular frame? This we make sure that there is a register which is counting the number of images, so that information is continuously fed to the ECU. If this counter gets stuck, then ECU will ECU will understand that okay, this camera is stuck, and that is how it disables this camera and takes itself to the fail-safe mode or the standby mode. So like that, there are multiple applications which are controlled or using this register data or the embedded data onto this. Now coming to the statistics or the statistical data, here it is at the bottom of the image normally. Uh, so this is like, for example, to control the exposure of the imager. So imagine how this exposure works is like when, say for example, our pixels, our iris uh, widens or narrows based on the amount of light is falling on that iris, right? So how this is happening? Similarly, the exposure also needs to be controlled. Say for example, we have a vehicle which is driving on the normal road and suddenly enters into a tunnel. So there the brightness level is reduced, and also it's going into a tunnel and suddenly comes out of the tunnel, the brightness, there is a more brightness. So to control this exposure, this statistical or data is calculated. There is a algo running how to calculate this statistical data, and this statistical data for each frame is embedded at the bottom of the every frame. Based on that, the ECU will take action on the next frame. So this uh, yeah, I think this is a some quick high level overview of how a actual image is captured and transmitted to the ECU. I think this brings to end of my talk. I have a couple of options which I have to say here. Like I was based on the overview what I got. So there are many cameras which are available in market. I mean, for a student project or a open source project, like what you are planning to do. Maybe some IMX sensors are there. Here I have mentioned it as a 219, may not be a 219. There are few IMX sensors which are suitable for this. I was also not only for this project, even earlier I have browse through the econ systems. They have some cameras which could be suitable for what you are looking for. There are few omnivision cameras or some other uh, aptina or the on semi what we have. So there could be multiple cameras which could be of interest to you, and the processing units could be Arduino Mega or Arduino Uno boards are there. Raspberry Pi, any Raspberry Pi, I think could be sufficient based on what or how mature your algos you are planning to do, and or a Jetson Nano could also support for your applications. So these were some of the options I could think. Uh, these cameras are typical to one of the camera what I have pasted here. Like we have a lens and the image processing and a, flex cable through which we connect it to the ECUs. So this typically is for our smart cameras. Uh, so yeah, this brings to end of my presentation. Yeah, if there are any particular questions or something like that, yeah, I will try to answer.
Yes, sir. Thank you, Mr. Venugopal Kulkarni, for explaining us the interfacing of camera with ECU for aBAJA. Before we proceed to the rulebook explanation, we would like to take up questions. So I request the participants to pose their doubts in the YouTube chat box. So we have a question. So do students have to do functional safety assessment by their own, or the HW and SW itself is standard compliance?
I think as a prototype, what you are designing there, I think functional safety and security are not very much relevant at this stage, right? It's like proof of concept. You are developing something and it works, and then maybe building at the next level, then the functional safety and cyber security things come into picture. Right at the initial stage or at the proof of concept or at the student level project, I think we don't need to get into this functional safety and cyber security things.
Okay, that answers your question, Harish. Participants are requested to pose their questions.
Vinay Mundra here. Hello, can you hear me?
Yes, sir.
Yeah.
I have another general question. We are talking only about the radar and not about the Lidar for the aBAJA vehicle. I just wanted to know why Lidar will not be required for the aBAJA vehicle.
This is Arun Shankar here. Maybe I can take up this question. Um,
Yeah.
So based on the, we had a look at the rule book, and what we have seen is for the sort of functions that we need to really have in our aBAJA vehicle, radars and cameras will do. So that is our initial assessment. And even when it comes to actual on-road vehicles, autonomous vehicles that we are building, usually all these lidar systems are required for level 3 autonomy, and that too on especially highways. But the aBAJA thing is different. It's of a different kind, wherein we believe that radars and cameras should suffice based on our experience. So that's, I hope, you know, uh, your question is answered now.
No, my submission is that, when we talk about our aBAJA, if you are going to very specifically design the aBAJA terrain for the competition in a manner that LIDAR requirements are not seen, that's a separate issue. But considering today's ATV terrain which we are using, even if we were to remove some of the obstacles, the kind of the turnings and the potholes and, ups and downs, whatever we have, and small hill-like situation here and there, I somehow feel that, could be some requirement of LIDAR. I may be wrong. I'm not too sure about it because I don't know about it. But this was a general feel which I had, and that is why I posed this question.
Yeah, usually, what makes you feel that LiDAR is important? Why can't a radar system itself achieve the same functionality? That would be my take on it. Maybe, do you have any reason why you think LiDAR
Yeah, well,
might be required?
I understand what you are saying. When it comes to LIDAR, what I feel is that you are able to see the obstacles in very close proximity and estimate or calculate the distance of the obstacle. Whereas with radar, it would be something which will be a longer distance and longer view. So there could be some issues only with radar and
Okay.
cameras.
Okay,
I,
I
I
get
I'm
your
not too
point.
sure. I'm not too sure. I'm
Yeah,
not
yeah.
too sure about it.
Yeah, yeah. I think, yeah, let me answer that question, because we work with all these problems day in, day out with a lot of our customers. That's why, we know what is good and what is bad. So let me answer that question. Uh, so radars have a range of up to 300 meters. And
Okay.
lidars have a range of up to 1 kilometer. That's because, all these we are, for all the short distance obstacles which are very close to the vehicle, radars really perform quite well. And lidar, of course, can only add to the redundancy, but lidars are not necessary uh, for a short, for a measurement or obstacle which is at a short distance. When it comes to a long distance obstacle, maybe that's why I'm saying LiDAR is required generally for level 3 autonomy on highways, because, on highways, when you are cruising at 130 kilometers or maybe, even higher speeds, you need to really have a very long distance view, so that you have enough time after you brake, so that the vehicle goes and stops even before it hits the obstacle. Okay, so radar is very much sufficient for a short distance your object detection. So that's my answer. So,
Okay.
yeah.
I think.
I think, we
What
will
you?
experience that. We will experience
Yeah, yeah,
that,
yeah,
and
yeah.
of
Sure.
course, if there are certain modifications or certain other upgrades which are required, we will. I think we will take it on. Along the way. Again, I'm saying
Okay.
these sensors, what we have, these are designed for highway and all those sorts of scenarios, right? That is where, when it comes to these off-road conditions, I think there might be some corner cases, certain new findings for us also. That is where we will, I think, we will have to learn together as we progress. Huh? Yeah.
I agree. No problem.
Yeah.
Yeah, we'll learn.
Thanks.
Thank you.
Thanks for your understanding. Yeah.
This is Dr. Sudhir Gupte. I think extension of whatever Madam Mundra sir was talking about and your reply, perfectly apt reply. Thank you very much. But will our students get to learn this lidar system as well? That is what probably Mr. Vinay Mundra was aiming at. Our student, this all the event is all about learning for the students, and they getting ready for the industry. So, through your team, will they be able to learn those entire complete gamut of autonomous vehicles,
Okay.
inclusive of cameras, radars, and lidars, and in more details of what Mr. Venugopal spoke about in detail? Will they
Yeah.
be able to learn?
Okay. Maybe at present, what we have decided is that we will Continental will support this event technically, so that the students are successful in the competition. Of course, the students also will have to put in the efforts, right? It's not about all the information coming from us, right? So, yeah. So to the extent which is required, we have already planned to really support, and the detailed planning is set to be done. But for sure, whatever is required on radar and and the camera is, of course, we will work things out as to what is,
Yeah.
whether if we give our camera, or should we really propose another camera from outside, considering the complexity and so on. Lidar is still not planned from to be included in the training. That's where if there is a special request, yeah, we can consider that. We can take it up internally, looking at the bandwidth and expertise available. We can see. Right now, I would not commit on it. Hmm?
I think that once we make one of our first proto vehicles, or the proof of the concept, or whatever your concept vehicle, things would be more clear
Yes.
uh, using whatever your system you are proposing. And if that is adequate, I don't think then we don't have to really look into. So I think it would be good and worthwhile, like we are making for H-Baha one vehicle. Similar way, if we make A-Baha one vehicle and start gathering the experience around
Correct.
that vehicle.
Yeah.
Yeah.
Right.
Thank you.
Yes, sir.
Thank you, Mr.
Yes, sir. We have another question. Is there any model or vehicle to benchmark from?
So, would any of the aBAJA organizing team members would also want to answer that?
Yeah, actually, we can always say that the vehicle is yet to get ready and getting tested. And as such, no benchmarking vehicle available, a Baha vehicle. Am I right, Arun? Anurag?
Yes.
Yes.
Next question we have, sir. Is there any role of CAN communication?
You mean the CAN communication, right?
Yes, sir.
Control.
CAN communication. Yeah.
Yeah, like uh, you receive the images, you have to, that is the sensing part, and then you have to actuate it. How are you actuating? Like, for example, if you detect a vehicle or something like that, so you have to send a signal to the brake system, right? So that happens over that CAN network. So that is again, a CAN is a protocol, so control area network. So based on CAN, these signals needs to be sent over to actuators. Also, for example, say a protocol, algorithm which needs to be activated, say at 20 kilometers per hour or 30 kilometers per hour. How will we know that vehicle is going at that particular speed? All these communications in between different ECUs happen over this CAN communication. So CAN is that communication.
Okay, so I hope that answers your question, Aditya. Next question we have is, what are the method steps required to calibrate the camera sensor?
Camera calibration itself is one bigger topic, right? So we need to that is a bigger topic. So we need to give the mats and try to plot within those mats. Camera calibration happens at a various stages. So we need to provide the extrinsics and intrinsics of these cameras.
Okay, so I hope that answers your question, Krishna. Next we have is Akshit is asking, when will the complete rulebook be released and when will be getting Lidar and cameras?
The complete rulebook we have planned to release at the earliest. Mostly by this month, we'll be releasing the complete rulebook. And with regards to the any other sensors or cameras required, we'll be communicating that to the teams. But always the teams are at the flexibility that whatever inputs they want to give to their central computing unit, so central computing processing unit, they are free to give. So if any additional sensors they want to map with their central computing unit, so that is also okay. The basic requirements, the basic servo motor requirements for the operational parts of the vehicle, that is acceleration, brake, steering. So those are the basic requirements. Other than that, if they want to map any additional sensors with the central computing unit, they can within the rulebook limits. Okay.
Rugved, I suggest after the first training is done for the students, then we can, identify as to what kind of inputs are required, addition, deletion, for the rule book already released. And then the final rule book can be released.
Sure, sir. We'll take that into consideration as well. Yeah.
Another question we have is, what are the basic system requirements for the particular designing?
So currently, as of now, in the draft rulebook also that we have mentioned, the basic system requirements will be, as we are converting a eBAJA vehicle to an autonomous vehicle, the three basic operational parts, as I mentioned, acceleration, brake, and steering. These are the three main operational parts. So servo motors can be mounted for actuating these parts with the help of the central computing unit. The central computing unit will also have to take input so that the vehicle is able to actually see. So for that, we will be mounting the radar and the camera sensors. And those will be the input data to the central computing unit, and the output will go to the accelerator, steering, and brakes through those servo motors. So these are the basic autonomous system requirements. And other than that, if they want to incorporate any other additional functional requirements as in suspension inputs to the central computing unit, they are free to do so.
Okay, perfect. So as of now, let's close the question and answer session. We will definitely conduct a complete particular session later. So I would now like to invite Mr. Rugved Ainapure to throw light on the rulebook of aBAJA. A little bit about him. He is a part of the organizing committee of BAJA India and a former member of the alumni committee. He is a Mahatma Gandhi National Fellow from Indian Institute of Management, Nagpur, and is currently associated with Ministry of Skill Development and Entrepreneurship, India. So that's all from my side. Over to you, sir.
Thank you, Anurag. Jaren, can you just share the screen, please?
Yes, I hope it's visible.
Yes. Can you go to the slideshow now? Hi, good evening, everyone. I thank Mr. Arun Shankar and Mr. Venugopal from Continental to give us a depth of insight into the autonomous vehicles and what the industry is doing, as well as the configuration of how a camera sensor can be configured with the central computing unit. Hope the teams who are participating, the 15 teams who are registered until now, they definitely have gathered some insights so that they can start designing of their software and other architecture. So moving forward to the autonomous BAJA rulebook. So currently we have released a draft aBAJA rulebook. You can visit the bajasaeindia.org website. If not, you can download it from the resource section there. So yeah, next slide. So aBAJA is divided into three phases, just like the ME and HBAJA. So first phase will be the preliminary round. The preliminary round will be at the start of the season. So the preliminary round will consist of two things. That is the presentation and online quiz. In the presentation, basically, detailed set of guidelines will be released. But basically, what the teams need to do is they need to give a preliminary presentation or a preliminary concept of the aBAJA vehicle that they are going to design throughout the year. Now, for the aBAJA vehicle, we'll also be focusing on in the preliminary round based upon how you are planning to design your software architecture, what all autonomous components you are going to integrate with your vehicle. And second is the online quiz. The quiz is of 10 points and it will be completely based on the aBAJA rulebook. The detailed guidelines will be released on the website. Yeah. Next slide. Moving forward to the phase two, the phase two will consist of the virtual static events. So we have six different virtual static events. That is the design evaluation, cost evaluation, sales, social responsibility report, EMI, EMC simulation, and safety report. So design, cost, sales are the same as we have been doing for the M&E events since the last decade or so. The new three events that have been incorporated for aBAJA are social responsibility report, EMI, EMC simulation, and safety report. So we will be like giving an overview of the same. The basics are of course the same, and most of the things are already available in the rulebook. However, a detailed set of guidelines for all the virtual static events we will be releasing as the time goes on into this season. While there are some bonus points available for some of the static events, as you can see. So the top teams after the first round of phase two, the top teams the number will be decided, and those top teams will be able to appear in the finals of the static events, which will happen on site at the time of phase three. So this is about the virtual static events. Next slide. Yeah. So social responsibility report. This event has been given 20 points this year. In this, basically, you know that there is a growing public concern as if a manned vehicle is going on a street where the pedestrians and other vehicles are moving, then definitely there
Raghuvat sir, I'm sorry to interrupt you. Can you hear me? Because we are not able to hear you. I think you've gone on mute.
okay. Am I audible now?
Hi, yes, sir. Could you please just go over the first point again regarding the public concern?
Yeah, okay. So as we know that there is a growing public concern whether if this new autonomous mobility system comes into picture, then there will be pedestrians driving, there will be other vehicles driving, and should this driverless car be a part of this currently existing ecosystem? So there's a growing public concern over it. Taking this as a problem statements, the teams will have to design 8 to 15 page report, and they have to give a presentation with regards to the complex issues of this new ecosystem. Second, the three things that they have to focus upon is economic, environmental, and social aspect of it. That whether this new ecosystem will be able to co-create or coexist with the currently existing ecosystem. And they have to also give a special focus on sustainability of this as we are moving towards the new generation as the technology is improving. So the autonomous system, whether it is sustainable in the long run or not. Can you go to the next slide, Devin? Yeah. So these are the basically some of the points with regards to what you have to add into your social responsibility report. Of course, we will be releasing a detailed set of guidelines regarding this, but this is just to give you an overview. So the benefits and risk of autonomous driving technology with regards to the environmental, economic, and social impact, and cost to benefit. So basically, how much cost the business is putting into it, business and society is putting into the autonomous driving technology, as against the benefit that we are getting. So these are some of the points that you have to include your problem statement while designing your report for the social responsibility part of it. Yeah, next slide. Design evaluation. So design evaluation will contain the same parts as the M and E, what we have been doing. All the subsystems need to be explained in the design report first, and then there will be a design presentation happening in the virtual static events, and then the design finals at onsite. But for the autonomous vehicle specifically, we would be also focusing on integration of system hardware with the vehicle, software interfacing to the physical controls, also the path planning and control architectures, how they have been designed, and if there has been additional thing that is VPS localization or map utilization data, which has been taken while route planning, and definitely the vehicle's reactions to the detection and avoidance of the static and dynamic objects. So this special emphasis will be given on these automotive systems at the time of design evaluation for the aBAJA vehicles. Next slide, please. EMI and EMC simulation. So basically electromagnetic interference and electromagnetic compatibility. So these are some of the crucial tests required for an autonomous car. So electromagnetic emissions, as you can see, generated by the car's electrical and electronic systems do not interfere with the operation of other devices, and that the car's systems are not affected by external electromagnetic emissions. So the key part of this event basically will be to demonstrate the test values of both of these simulation tests. So you can use different software, that is HyperWorks, ANSYS, COMSOL, for performing this test, and then a report needs to be presented. What results, what test values have you gotten, and whether they are validating with what you had designed them for. And accordingly, the 25 points will be distributed based on the team's understanding and how the teams presented, what type of simulations the teams have carried, and the comprehensive depth of knowledge that they have gathered through. Yeah, next slide, please. And yeah, lastly, the safety report. So throughout the year, once the autonomous vehicle has been designed, the teams will be carrying out the testing at their college or any other testing tracks before they participate with the physical vehicle in the phase 3 of the competition. So they have to maintain the safety records throughout the year. If it is possible that at the time of architecture designing or at the time of interfacing with the software interfacing with the hardware of the vehicle, so there might be some issues that you will face at the time of testing, which you will rectify before like building the final vehicle and before appearing for the phase 3 event. So all the safety records you need to maintain. Had the vehicle at any point of time underperformed, or had the vehicle any point of time like overridden the set of inputs that it had been given. So all of this needs to be documented, and the date, time, and incident, and the description needs to be like comprehensively detailed out, and that will be checked at the time of the presentation of the safety report at the time of phase 2. And the second part will be the interface analysis report. So this will basically be an analysis document. So to identify the potential functional interactions between the system and other vehicle systems. So basically between the autonomous system and between the other vehicles, operational and functional systems of your physically built vehicle. So this will we will be actually seeing whether you have identified any critical hazards in the preliminary hazard analysis, and what measures have you taken to counter it in the final system architecture of the final design vehicle. Yeah. Next slide, please. So moving forward to the aBAJA phase 2 virtual dynamic events. So ATS, that is automotive test systems, we are partnering, we are collaborating with them just like the past 3 years. So they will be providing softwares of IPG Automotive. So a particular number of software licenses per team would be provided, up to 5. So after that, a training will be given upon how to design an aBAJA vehicle, and the team needs to design a virtual aBAJA vehicle as they will be doing the physical aBAJA vehicle parallelly. Next slide, please. So before virtual dynamic events, after the training, they can utilize the IPG car maker software. So before designing the physical vehicle, they can see what inputs they are getting through the software and what optimization they need to do, so that once their physical vehicle is in the making, they will save time on the physical testing. So if they have already used the simulation part of it to see what kind of results they are getting, and have optimized the vehicle before starting of their manufacturing, then they will definitely be getting an advantage. So virtual dynamic events is basically software in loop. So whatever virtual vehicle that you will be designing, you can create different road scenarios and traffic objects on by designing it on IPG car maker, and you can test your designed aBAJA vehicle on those design tracks, such that you will see how your vehicle is performing for the optimization part of it. Next slide, please. So there will be 8 virtual dynamic events basically, as you can see. Autonomous emergency braking to check the capability of braking of the autonomous vehicle within a certain patch. As all the aBAJA vehicles will be restricted to a speed limit of 30 km per hour So a particular pass length will be predefined. So the vehicle needs to stop in that particular pass length, and depending upon that, the points will be given. ACC is adaptive cruise control. So this will be kind of similar to what we do in the acceleration event. Then vehicle to stationary object, vehicle to pedestrian. So these will be the tracks for first four events. Then lane departure warning and lane keep assist. So as you can see that there are two specific events for the lane departure warning and lane keep assist. You need to mount the indicator lights on the front and rear for the aBAJA vehicles, which is an addition to the autonomous system. So these will be particularly crucial for these LGW and LK, these two events. And then object detection and avoidance, in which there will be a particular predefined length of the track, in which there will be some road banking, there will be some turns, and there will that will be that will be a plain track this year. There won't be any hard bumps or droops, but there will be obstacles placed and there will be turns and banking on the road. So as to check the ability of the virtual vehicle to detect and avoid the obstacle. And then finally, there will be alternate performance event. Next slide, please. Yeah. So aBAJA specification sheet. So we, along with the vehicle specification sheet, in which you have to define all the subsystems, what is your the specifications of all the subsystems, basically the powertrain, suspension and steering, roll cage, and all the steering. So all the subsystem specification sheet as you give for aBAJA events. This year for the aBAJA event, two new things will be added in the aBAJA specification sheet. That is the hardware integration overview and software integration design. So hardware integration overview will consist of the details of the sensors and components and the other camera, radar sensors that have been used in the vehicle. And software architecture design will be how you have configured your central processing unit with it. Yeah, next slide, please. Basic requirements of some of the basic requirements of aBAJA have been listed here. That is, if certain hazardous conditions occur, then there should be a facility for the vehicle to stop, wherein the vehicle comes to standing still and switches off all the powertrain systems. So same like the kill switch. Once you press the kill switch, the car is the powertrain is cut off. Same facility needs to be available here. One new thing that we are introducing here is that the teams need to also have an additional remote kill switch available with them, so that if when the team is attempting any of the dynamic events at the phase 3 event site, so at the and in the autonomous mode, a team member needs to be present there, wherein he needs to have the remote kill switch in his hand. That will be tested, and then only the team will be attempting that track in the autonomous mode, considering the safety aspects of the autonomous vehicle. The maximum speed limit will be 30 km/h for all the aBAJA vehicles. There should be a switch in the vehicle easily accessible to the driver to switch between manual mode and autonomous mode. So the vehicle is at the time of phase 3 only within the limits of the dynamic event tracks. The vehicle will be in the autonomous mode. For the race stall event area, if the vehicle needs to be brought out of the pits, it will be driven by a manual driver only. And then manual mode is basically driver has full control of the vehicle and overrides the autonomous functionality. While autonomous mode is there is no physical driver present in the vehicle. Vehicle has self-driving ability. And one specific thing that you need to ensure throughout the year while building your physical vehicle is that wiring of all the sensors needs to be proper. As this will be a completely driverless vehicle, there should be, you must see that all the routing of the sensor wires or all the routing of any other electronic components or electronic systems present in the vehicle, they need to be contained within the roll cage envelope, and there should not be any open ends. Yeah. And next slide, please. So blue autonomous warning light is one more thing that we are introducing. So there will be basically two blue autonomous warning lights. One will be an exterior blue light, which will be mounted up on the vehicle. That is on the top members of the roll cage, and the interior blue light, which can be mounted near the dashboard. So this basically the operation of the blue light will ensure that the vehicle is truly in the autonomous, that is the driverless mode. So that's why the blue autonomous warning lights will be necessary to be put forth in the vehicle this year. Next slide, please. Indicator lights and remote kill switch, as I already covered it. Two at the front and two at the rear, and then the remote kill switch as well. Next slide, please. So just to understand, the remote kill switch will do the same thing that the kill switch mounted on the vehicle will do. Once if the remote kill switch is pressed due to any safety hazards that are being foreseen on the dynamic event track, then it should cut off the vehicle remotely, so that the track marshals or the volunteers can go on and they can take back the vehicle to safety. Yeah. So aBAJA autonomous components. So basic components, that is servo motors for controlling the operational components of the vehicle, that is accelerator, brake, and steering. These basic three things need to be controlled through the servo motors, and any additional things the team can have the flexibility to within the rulebook constraints. Radar the Continental will be providing us a premium long range radar ARS 548 RDI. So you can the details of these are available on the internet as well. You can scroll through it, see what are its features and specifications. For the camera, we had a good session by Mr. Venugopal sir just before my talk. So you can research on the cameras, how they need to be configured with the central computing unit, what type of cameras you need to use with respect to your vehicle design, and how much input data you want to give to your central computing unit. Accordingly, the camera can be selected. It must be selected such that it is able to identify various lane markings. Because it is an autonomous event, all the dynamic event tracks will have specific lane markings, specific signs, and specific flags. So we will be releasing what will be the road signs, what will be the lane markings. Everything will be defined so that you can like configure your cameras to identify these lane markings, and the vehicle is able to identify the road constraints and able to move only between the road constraints. So different road markers and stationary and moving object identification. So that will be the main agenda of mounting the camera on the vehicle. And then the central computing unit, you have to interface the software and hardware components with the central computing units, all of the electronic components. Yeah. Next slide, please. Now moving forward to the last part, that is the phase 3, the dynamic events. We will be having a total of 9 dynamic events on site. All of these will be on site conducted with the physical vehicle that the teams will be bringing. The validation event, basically, it will be a hardware in loop event. So the virtual vehicle that you had designed previously in the phase 2, that virtual vehicle's output will be validated with respect to the physical vehicle. So that to see that how much your virtual design is in validation with your physical design, and accordingly the points will be distributed. And some of the events, most of the events are same with the virtual dynamic events. That is, you can see the braking event, acceleration, that is adaptive cruise control, vehicle to stationary object, vehicle to pedestrian, the lane departure warning and lane keep assist event, object detection and avoidance, and finally the endurance performance event. So for the endurance performance event, the detailing would be done forward in the final rulebook that we'll be releasing. Like it will be of a single lap or it will be of a predefined number of laps. Being this year being the first year of the aBAJA, there will be not much of the group, but there will only be some stationary and moving objects placed on the track. We'll try to keep the track this year as a plain track, so that the teams are able to perform, like we are able to improve upon the next year based on the performance that the teams are able to show in this year's physical dynamic events. Yeah, next slide, please. Then the aBAJA technical inspection. As you know that before when you come on the physical dynamic event side, so before participating in any of the physical dynamic event, the team needs to go through a technical inspection. So technical inspection will basically be to check all of your vehicle whether it is within the constraints of the rule book. For autonomous vehicles specifically, the indicator lights, the working of them, hazard lights, blue autonomous warning lights. Then with regards to the drivability part, the interior displays and whether the software is interfacing properly with the hardware, whether the data of the radar's camera sensors is in line with what the central computing unit is getting, whether all the wirings are routed properly and are contained within the roll cage envelope. So this will basically be checked. The technical inspectors will be cross-checking your vehicle with regards to what constraints have been given in the rule book. So if you are not able to fulfill any constraint, then you will be asked to rework on the vehicle before you are given the final clearance of the technical inspection. And after the final clearance of the technical inspection is given, then only any of the team will be able to participate physically in any of the physical dynamic events. Next slide, please. The dynamic event attempt procedures will be that the vehicle will be brought to the start line of any of the dynamic events by a manual driver. Then the autonomous mode will be switched on. And then when everyone and the track marshals are ready, the remote kill switch is ready with one of the member of the team attempting, then only the go ahead will be given, and then the team can attempt that particular dynamic event. Speed will be restricted to 30 km per hour. The complete list of the flags and what each flag will denote will be provided in the final rulebook. So a green flag will be waved to so that the vehicle is able to know that the it is clear to attempt that particular dynamic event. And after the finish line, the vehicle needs to be stopped. The autonomous mode will be switched to the manual mode, and then the manual driver will take the vehicle out of the track. Next slide, please. So lastly, we have the overall scoring summary. You can see that the 1100 points teams will be accumulating, maximum of 1100 points teams will be accumulating throughout the years, participating in various events. So a tentative schedule has been already provided in the draft rulebook of all of these events as well as the guidelines. So the final schedules will be informed to the teams, and the teams have an opportunity to grab these many points in different phase 1, phase 2, phase 3 events. So they have to plan their schedules accordingly. So 100 bonus points they will be getting in the static events, and the rest 1000 in the preliminary round, virtual static dynamic events, validation, and the physical dynamic events. Next slide, please. So way forward in aBAJA basically. Final rulebook will be released in like at the earliest possible time. Within this month, we are trying to release the final rulebook so that you will have a good amount of idea how you need to design the vehicle forward. But with the help of draft rulebook, like I will suggest the teams, and with the help of, as you already know, which type of radar you are going to use, and with regards to the workshop that Mr. Venugopal had currently conducted with regards to how to configure the camera and all. So you can start parallelly working upon your vehicle so that once the rulebook is like finalized, you will at least have some data to work forward with. Then additional workshops will definitely be planned for the aBAJA teams so that their learning aspects are increased and you are able to build a proper sturdy and a reliable autonomous vehicle definitely. And BAJA India organizing committee is definitely always there, and our sponsor partners are always there to support you so that we are able to successfully conduct this first year of autonomous BAJA India. Then different flags, road signs, and lane markings, which shall be used in the physical dynamic units. They will be also specified in the final rulebook, so that you need to design your system architecture such that your vehicle is able to identify all the flags, road signs, and lane markings which are mentioned in the rulebook. So that needs to be taken care of. Because these are the things that we'll be using in the physical dynamic units when the vehicle is going to be driven in the autonomous mode. And lastly, the detailed guidelines of all the static events shall be released. So once all the registration procedures are complete, all the teams will be getting a BAJA India forum account. So you can post any of your queries on the BAJA India forum, and we'll try to like answer them within 1 to 2 weeks of time. So forum is a good platform which can be used for interaction with the organizing committee for any doubts that you have. Until and unless you don't have your forum accounts, you can always drop a mail to BAJA India Communications so as to resolve any of the doubts that you have. Next slide, please. So thank you so much. I hope most of the things are cleared by after this workshop. We'll be surely planning some more workshops in the coming months so that you get more clarity on what type of and how you need to design your aBAJA vehicle to be. But I would definitely suggest that you start right now so that you have at least have some amount of knowledge, and then you will be able to build upon it. You can get back to us at any point of time with regards to any queries that you have with regards to the aBAJA vehicle. And once the forum accounts are in place, you can use the forum as as you know, a uh, virtual point of contact for interaction with the other teams as well as the organizing committee. So through forum, most of the teams will be able to like clear your doubts, and definitely all the best to all the 15 teams who have registered. We have high hopes from every one of you, and BAJA India is there to support you to make this first year of autonomous BAJA India a huge success. Thank you, and over to Jerry.
Yes, thank you, sir, for shedding light on the aspects the team must focus on during the development of their aBAJA vehicle. So, participants, if you haven't had the chance yet, the aBAJA rulebook for the 2024 season is available on our website under the resource section. So now we will open up our live chat again for any questions that you have regarding the aBAJA event or the aBAJA rulebook. Yes, sorry, I was having some technical issues. So Rigvit sir, while our participants are forming their queries in our chat, so perhaps you could just explain a little bit more on the static event guidelines, like if a template as such will be released for the safety reports that teams have to form so that they will have some more confidence in these events in particular.
Yeah, Jerin. So as we have been doing it for the design event, cost event, and the sales event, so we will be releasing a template, not specifically a template, but definitely what all sections they need to add in their safety report, how the table should look like, the incident report table should look like. So all of this will surely be released to them in the detailed set of comprehensive guidelines that we will be releasing.
Okay. And now we have a question from Abhinandan. What will be the approximate cost of the equipment, the cameras, radar, etc.? I know it's difficult to pinpoint an exact amount, but perhaps a range so that teams can prepare their budget accordingly, sir.
Currently, I don't think that I can comment on the range, but surely currently the radar sensor that will be provided by the Continental will be definitely releasing, as we have been releasing it for any of the that is the engine we release for aBAJA, the complete pricing list. So that we will be releasing for the radar, and we will also see to it if we are able to release it for the sensors, or the teams can decide whichever sensor the cameras that sustains the capability of that the autonomous vehicle should have specifically within the constraints of our physical dynamic events. Those camera and those sensors, the teams will have the liberty to choose. So the range can be specifically the teams need to do some market research at their end as well. They have to study the specifications of the camera sensors provided by different companies so that they are able to like decide upon which type of they are able to finalize upon which camera and which sensors they need to mount. So that will be completely subjective to the team's requirements.
Understood. So there is a question regarding the track of the dynamic events. So can they expect a typical off-road racing track or will it be different for aBAJA vehicles?
Yeah, so for aBAJA vehicles, we will be this year going with a plain track and not a typical off-road track with much bumps and ropes and much obstacles. But definitely we will have some stationary obstacles and we'll have some moving obstacles in place on the track. But the track will be a plain track.
Okay.
So a stationary obstacle will mean that we'll be placing some stationary obstacles like a person or a stationary vehicle on the track, which the autonomous vehicle will have to maneuver through, but not the stationary obstacles like wooden logs or something. So the teams will have a plain track to go on, but there will be stationary obstacles which the teams have to avoid and maneuver through.
Understood. Thank you, Rugvit sir. I hope that answers your question, Sandeep. So, Rohit, sir, do you have any tips for aBAJA teams in the current stage right now while they are preparing for their preliminary round to get them started with?
So I guess that most of the teams would have already participated in the aBAJA event of 2023 or 2022 who are participating in this year's aBAJA event. So they can like parallelly work upon the current design of their aBAJA vehicle, basically so how they have designed their steering, accelerator, and brakes, that is the operational components of the vehicle. So they can start choosing the servo motors because servo motors are one of the things that the teams have to choose at their end depending upon how much torque output they are getting on the steering, how much like while the vehicle is driving on track, so how much input they are receiving from the road, the feedback from the road basically, and accordingly they have to decide upon which type of servo motors they have to use, and they can finalize upon that. So as they already have the aBAJA vehicle of last year or last to last year with them, they can already start with designing of their servo motors. The autonomous components can definitely come into a later stage, but they can some of the members we had already mentioned in the rule book that we need some of the members from the computer IT electronics domain as well as a part of the team. So these members can definitely start working upon how these servo motors for these operational components need to be configured with the central computing unit, and which type of the radar they already know which type of radar they need to use, but the camera and which type of different sensors they need to configure with the central computing unit. And then the output that needs to be given to the servo motor. So the programming part of it, the teams can like start upskilling themselves, or if they already have someone who is properly skilled in that particular programming domain, then they can start applying by using microcontrollers like Arduino for so as to start, and then they can build up upon what they really need to implement in their physical vehicle further.
Okay, and we have a question from Sandeep again. Do we have to use separate servo motors for different applications, or we can use just one?
No, so servo motors for these three components specifically, that is accelerator, brake, and steering, they need to be separate. There won't be a single servo motor for these three components. Other than this, if the team needs to like give any additional output as an operational part of it, then they can decide based upon their system design. But for these three components, at least the basic operational components, that is accelerator, brake, and steering, they need to have different servo motors.
Understood. There is a general question regarding the registration for aBAJA now. So Rupert sir, could you comment on that?
Can you elaborate more on the question?
So the question is, are the registration open for aBAJA?
So if we have closed the registration, but still if any team is willing to participate, then they can drop a mail to BAJA SAEINDIA Communication, and we'll definitely see whether we can accommodate. This being first year of autonomous BAJA, and we are just starting the season, so we can surely take in any new team that is willing to participate today as well.
Understood. So thank you very much, Rugved sir, for all your insights. I'm sure it has helped the teams a lot. So to conclude this webinar, I would like to call upon Mr. Jay Shah to deliver the vote of thanks. Jay has been associated with BAJA from being a participant to being a member of the alumni committee to now leading the team as head of the BAJA SAEINDIA alumni committee. Over to you, Jay.
Thanks, Jerry. Thanks for introduction. So on behalf of BAJA SAEINDIA, it is a great pleasure for me to extend my heartfelt thanks for each and every one of you who is involved actively and their invaluable contributions to this insightful workshop, which was on camera and sensors for aBAJA vehicle. So first and foremost, I would like to thank Mr. Arun Shankar and Mr. Venugopal Kulkarni from Continental, who shared their profound knowledge, expertise, and experience in the field of autonomous vehicle. We would also like to thank Mr. Rugved Ainapure for taking us through the rule book for autonomous BAJA. I'm rest assured that teams have got a good amount of idea on how to move ahead with the concept and make the strategies accordingly for the upcoming year. I would also like to thank Dr. K.C. Vora for taking us through the history of autonomous BAJA and what all went in for bringing this new event format for BAJA SAEINDIA. So as we conclude this remarkable aBAJA workshop, let us carry forward the knowledge gain, and we hope this workshop will serve as a catalyst for all the teams as well as for all the students who want to grow in this autonomous mobility field. We look forward to your continued support and participation in our future endeavors. And thank you once again. Have a splendid day ahead. Thanks.
Jay, I would just like to add one more point. So in the rule book, there is a last section that is SAE technical standards. So we have included specific standards which are relevant for autonomous vehicles. So I would recommend all the participating aBAJA teams to once go through that SAE technical standard sections and refer to all the aBAJA relevant standards, which are readily available on the website. Some are available on the ARAI website as well, so that they will have a more idea into it. Over to you, Jay. Thank you.
Thanks, Rugved. Thank you so much. Yeah.
Yes, so thank you, Jay. I guess we can conclude today's webinar. Once again, our heartfelt gratitude to all our speakers. Thank you to all our attendees. Wishing you all the very best for your future participation in the competition. Thank you.